We are now solving problem 20 from the Amc 10B from 2019. As shown in the figure, line segment AD is trisected by points B and C so that AB is BC is CD is 2. 3 semicircles of radius 1, AEB, BFC, and CGD, have their diameters on AD and are tangent to line EG at E, F, and G, respectively. A circle of radius 2 has its center on F. The area of the region inside the circle, but outside the 3 semicircles, shaded in the figure, can be expressed in the form A over B times pi minus the square root of C plus D, where A, B, C, and D are positive integers and A and B are relatively prime. What is A plus B plus C plus D? This is a very rough sketch, but this is like basically the gist of it. This big circle has a radius of 2. So, in order to find this shaded region, what we can do is we want to ideally just find this might be really hard to do, but we can sort of break this up into different sections so we can only worry about them. Now these 3 semicircles are equal, but the main thing we notice is that when you draw this line, it's supposed to break in half like this. So this top part, shaded region, this is just, since the radius is 2, this is 4 pi over 2 is 2 pi, because the area of a circle is pi r squared. Now let's move on to these shaded sections. They're like abnormal bended triangles. And now these might actually remind you of triangles because we can construct lines EB and FB. And similarly, we can do FC and GC, but since they're both the same, I'm not going to do that. Now, how can we visualize this area? Or rather, this area? Well, we know that since this is 1, since the radius of the semicircle is 1, we also know that the height is going to be 1. So, whatever it's going to be like 2 times the base or something like that over 2. So, basically, what we can do here is we can now determine this side length, what this leg is. Since, we can construct an arc like this with 1 and 1 here, and then we draw this line like this. That's directly going through, that touches these 2 points. We can now form an equation of the entire, semicircle, this quarter of a circle. This is pi over 4 minus the area of the triangle is 1/2. So, we have this. Now, basically, since there's 2 of these, we want to multiply that by 2. So, and then we have to, so, the whole area of this triangle is 1, because they all have side length of 1. So, the reason it's 1 is because since this is 1 and this is 1, this base is going to be 2, which indeed satisfies the radius 2 thing. So the area is just 2 times 1 over 2 is 1. So the total area is going to be 1 minus, well, there's 2 of these on each triangle. So 2 times the area. This is the area of this. Just to be clear. So this is 1 minus 2 times pi over 4 minus 1/2. But we notice there's 2 of these triangles. So in this, we multiply by 2. And when we add and subtract and stuff like that, we get that this is 4 minus pi. Okay, well, now we've actually tackled this part, these 2 sections. Now we just gotta find what this is. That might be a bit harder, but we can do that. Since this is an arc, we can draw lines like this to the edges. and this is an arc of 60 and 60 degrees. Since this is a 90-degree angle, we notice that this is a 30, 60, 90-degree triangle. This is 30 degrees, this is 60, and this is 30. So, another thing we notice is that by 30, 60, 90 triangles criteria, we know that this smaller leg is going to be root 3. So, this entire leg is going to be 2 times root 3. So, since this entire leg is 2 times the square root of 3, and the height is 1, we have to multiply by 1 and divide by 2 to get this triangle's area of square root 3, which is going to be very helpful because if we can find this total arc area and then we subtract root 3 of it, we get this shaded area. Now, what is this? As previously stated, it's a 30, 60, 90-degree triangle. So 120 over 360. This is 120 degrees out of the total 360 degrees. This is 1/3 of the circle. Since the area of the circle is 4 pi, then that means the area is 4/3 pi. Since you have to subtract this triangle that has area root 3, we subtract that. And we want to add all of these things up, and we want it in the form of a over b times pi minus c plus d. So we have this as an area, we have this as an area, and we have this as an area since we broke it up into 3 regions. So this is 2 pi plus 4 minus pi plus 4/3 of pi minus the square root of 3. And this is a minus pi, so this just becomes pi plus 4 plus 4/3 pi minus square root of 3. So if we want it in the form that the question's wanting us to do, this is 7/3 pi minus the square root of 3 plus 4, where we indeed have it in this form right here. So our answer is going to be 7 plus 3 plus 3 plus 4. That's 10 plus 7 is our answer of 17. We are done.